Hello friends, I am astrophysicist Devendra Sharma and this is my YouTube channel Astrophysics for you. As you are looking, I am in black. Today I am talking about something that is really black. Yes friends and dear student, I am talking about the Nobel Prize in 2020 in physics. The Nobel Prize 2020 was shared between three astrophysicists. Half of the Nobel Prize goes to Roger Penrose, who is a professor at the University of Oxford, UK. And half of the Nobel Prize was shared between two professors, Professor Andre Ghez and Professor Renard Genzel. Professor Andre Ghez is a professor at the University of California, Los Angeles. And Professor Renard Genzel is a professor at the University of California, USA. So, before further discussing about why these eminent physicists get Nobel Prize in physics for the discovery of black hole, we need to look a little bit about the black hole. What exactly is black hole? Friends and dear student, black hole is a final death state of star whose mass is much higher than the mass of our sun. When star exhausts all fuel inside it, then it shrinks under its own gravity up to Schwarzschild radius. Then a black hole becomes a region in space. Its gravity becomes so high that even light cannot escape from it. This is because of accumulation of huge amount of matter in an infinitely small point that is called black hole singularity or gravitational singularity, or we can also say that gravitational collapse. And firstly, I'm going to tell you that why Professor Roger Penrose get the half of the Nobel Prize. Because Professor Roger Penrose proved that black hole formation is the robust prediction of general theory of relativity. 10 years after the death of Albert Einstein, Professor Roger Penrose studied that general theory of relativity very deeply and makes a mathematical modification in general theory of relativity and published the research paper named by gravitational collapse and space-time singularity in 18 January 1965, in which he discussed that if we have sufficiently big bodies of great mass, of spherical symmetrical body, if we contract that body inward and continuously contract inward and inward, then a physical situation achieved when the radius of that spherical symmetrical body becomes zero. When r becomes zero, that situation is achieved, which indicates that the physical singularity is achieved at that situation. In his research paper, he also involved the Kerr solution. That Kerr solution also suggests that physical singularity is necessary developed in spherical symmetrical body, because spherical symmetrical body when collapse inward and inward, then space-time catastrophe attained, which indicate the formation of black hole. And in his research paper, Professor Roger Penrose suggests a trapped surface, and that trapped surface indicates for the formation of black hole, for the formation of physical singularity. For this discovery, Professor Roger Penrose got the Nobel Prize, and half of the Nobel Prize goes to Professor Roger Penrose for the discovery of that black hole formation is the robust prediction of general theory of relativity. Friends, now we will discuss about that why Professor Andrea Ghez and Professor Renard Genzel got the half of the Nobel Prize. What they had done so special in astrophysics so that they got the Nobel Prize? Let me tell you that Professor Andrea Ghez worked at the Keck Observatory, Hawaii, and Professor Renard Genzel worked at the European Southern Observatory, Chile. These two astrophysicists work at different observatory and makes the observation approximately 25,000 light years away from this earth at the center of a Milky Way. They studied the orbital motion of star at the center of our galaxy, that is Milky Way. They observed the dancing of star around the center of our Milky Way. As you know that it was believed that earlier at the heart of our galaxy there is a supermassive black hole. To prove it, there is really a supermassive black hole. These two physicists were taking observation. These two physicists were deeply mapping the nearby star around the Sagittarius A star. Sagittarius A star is supermassive black hole at the center of our galaxy. So these two physicists make the observation. They observe the orbital motion of nearby star around the Sagittarius A star. They observe that when these nearby star comes nearer to Sagittarius A star, their orbital velocity get increased. When these stars go away from the Sagittarius A star, their orbital velocity get decreased, and they act like a dancing around the Sagittarius A star. And they think that what is going on there? What is happening at the center of our galaxy? Why these stars are dancing, act like dancing around center of our galaxy? So they think that there must be something. There must be some massive object, supermassive compact object at the heart of our galaxy around which these nearby stars are dancing. When they comes close to center, their orbital velocity get increased, and when they move away from the center, their orbital velocity get decreased. What is happening? So they observe some of the approximately 30 nearby star. Some of them are S1 star, S2 star, S12, S13, S14 and S8 star. Especially they observe the motion of S2 star, which is closest to center of our galaxy, as it was believed that center of our galaxy is occupied by Sagittarius A star, which is supermassive black hole. So these two physicists observe the orbital motion of S2 star. They find out that when S2 star comes nearer to Sagittarius A star, as it approach Sagittarius A star, its orbital velocity get increased, and it goes and move away from Sagittarius A star, its orbital velocity get decreased. So this proved that there is black hole, there is supermassive black hole, which was earlier named as Sagittarius A star. Now, second thing, what was surprising about S2 star was that when it comes near to Sagittarius A star, its nearest point in each turn, in each cycle changes. And when its nearest point changes each cycle, then its shape formed like a Rosetta shape, not like a ellipse shape, which was suggested by John Kepler. Its shape was not observed elliptical, and its orbital period is 16 years. Last time, the closest approach of S2 star to Sagittarius A star was in 2018. and before it was closed in 2002. Now let me tell you about the Sagittarius A star. Sagittarius A star is 4 million times massive than our sun, and as for the S2 star, it is 15 times massive than mass of our sun. To observe the star motion around the Sagittarius A star was just like to measure the fuel in the ocean, because between Sagittarius A star and our Earth, our telescope, there is a atmospheric disturbance, atmospheric air turbulence, and turbulence in space caused by gases and dust cloud. So it was very typical to measure the orbital motion of these stars around the Sagittarius A star. The size of Sagittarius A star is not bigger than our solar system, and Sagittarius A star is now proved to be a supermassive compact object at the center of our galaxy, whose gravity is impacting the nearby star motion. Because when planet revolving around the sun, when it comes close to sun, its orbital velocity get increased. When it goes away from the sun, its orbital velocity get decreased. Same thing is with black hole and star that is revolving around the black hole. When it approaches the black hole, its orbital velocity get increased. When it goes away from black hole, its orbital velocity get decreased. Same thing was happen with this S2 star and all other nearby star at the heart of our galaxy. Prove that at the center of our galaxy there is supermassive compact object. And for this discovery, these two physicists shared the half of the Nobel Prize. So in this video I have told you that about the Nobel Prize in Physics 2020 for the discovery of black hole. Half of the Nobel Prize was got by Professor Roger Penrose, and half of the Nobel Prize was shared between two eminent physicists, Professor Andrea Ghez and Professor Renard Genzel. We will meet in next video very soon. Till then, you take care.